Hey, in this lesson, I'm going to teach you how to solve by factoring. So it's really going to go along with my previous two videos on factoring. You're going to definitely need those skills for this video. When you're solving by factoring, you're finding where the particular quadratic crosses the x-axis. So you might hear this as solving for the roots or solving for x or finding the solutions at x-intercepts, maybe worded differently. But basically, if you were to graph the quadratic, you're finding where it crosses the x-axis. So when y is 0, you're finding x. And all you need to know is how to factor, how to solve, and this zero product principle. So the zero product principle says that the product of two numbers is zero. Sorry, if the product of two numbers is zero, then at least one of the factors is zero. So if A times B equals zero, then either A equals zero or B equals zero or both. So if we're going to solve by factoring, then usually you have an equation, a function, where it'll say, y equals 5x squared plus 7x minus 6, or f of x equals 5x squared plus 7x minus 6. And you're solving for x, and when you're doing that, you're looking for the x-intercept, which means that y is 0. So that's why we have to have 0 over here. It has to always be equal to 0 in order to use the zero product principle. So we're just factoring, and then we have one more step. And we know how to factor. So what we're doing is we're factoring this, and then I'll show you what to do after that. So if we're going to factor this, we're going to take factors of negative, 30, and figure out which ones add to 7. So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Looks like these are going to be good. We're going to have a positive 3 and a, nope, did that wrong. Sorry, guys. Negative 3 and positive 10. So those multiply to negative 30 and they add to positive 7. Sorry about that. So I'm going to write this with my shortcut, x minus 3, x plus 10. And remember, we have to deflate it by that coefficient. And we get 5x minus 3 and x plus 2. And now this is where the zero product principle comes into play. So everything we've done so far, we've already learned. So none of that's new stuff. The only new part is the zero product principle. We have A times B equals 0, means that either A or B or both equals 0. So what you're going to do here is you're going to split up your factors. I usually go like this. And I set each one equal to 0. And this is where solving is going to come into play. So we're solving for x. We're going to add 3 and divide by 5. On this one, we're going to subtract 2. We have x equals negative 2. So I have two solutions here, and we write that with a solution set, and you start with the smaller solution. And that's it. That's all at once. You also could write this as negative 2 comma 0 and 3/5 comma 0, but I think this is more common. But that's all. You just factor, and then you split it up, and you solve. The end. So I want you to try on your own this one. Pause it, try it, come back. So for this one, you're looking for factors of 3 that add to 4. That is 3 and 1. You write that as x plus 3, x plus 1, or flip-flop those. Split them up, set them equal to 0, subtract 3, subtract 1. We get negative 3, negative 1. So you write that as a solution set, and that's it. Okay, the next one, pause it, try it, come back. This is a difference of two squares. So we're looking for factors of negative 100 that add to 0. That's going to be negative 10 and positive 10. Set those up as factors, x minus 10, x plus 10, set them equal to 0. Solve this. These are simple solving problems. Plus 10, minus 10, you get positive 10, negative 10. And those are your solutions. So that's it. Pretty easy, right? Okay, this one, I wanted to bring up something like this because sometimes students see this and they get freaked out. This is already factored. We have x times x plus 2. So sometimes your instinct is to multiply that out and then try to factor it. And you're like, oh my gosh, what am I doing? Just leave it. It's already factored. So right here, we can just go straight to the product principle. So we have x equals 0 and x plus 2 equals 0. X equals 0 is already solved, so I don't really need to do anything with that one. And then we have x equals negative 2. So our two solutions are negative 2 and 0. Now this is a good example to show you that on. I want to show you the graph of this. It's not really the point of the lesson, but I think it'll be cool anyway. Plus, we love math and we love to explore, so we're going to do it. X times x plus 2. So I'm just going to write it in exactly how it is. And then I'm going to go to graph. And I have a statistics plot on here. We can see, if you look, it's a U-shaped graph. And where does it cross the x-axis? Remember, x is horizontal. Where does it cross the x-axis? Negative 2 and 0. So that's what we're finding. We're just finding it algebraically. And if I were to look at the table, at 0, the y value is 0. And at negative 2, the y value is 0. So that just confirms. So that's algebraic with a table and with a graph. They all are the same. That's what I love about math. I love a lot of things about math, but that's one of the main things. Okay, this next one again is a little bit different. Technically, this is not even a quadratic, but I wanted to put it in there just to kind of show you. Just in case. So this one is a cubic function. This is x to the third. And then we have negative 5x squared, negative 14x equals 0. If you notice, you might look at this and go, oh my gosh, I don't know how to do that. And that's fine. It's really simple. If you notice, they all share an x. So the first thing I'm going to do is pull out an x. If I pull out an x from x to the third, I'm left with x squared. If I pull out an x from negative 5x squared, pull out one of those, I'm left with negative 5x. And if I pull out the x from the last term, I'm left with negative 14. Now, this is starting to look more familiar. X squared minus 5x minus 14, I can factor. That is a quadratic. So that's kind of why I put it in here, because it's disguised. It's still a cubic function because we have this x outside, so it makes it cubic, but just go with it. Looking for factors of negative 14 that add to 5. That's going to be negative 7, positive 2. And then we can still use the zero product principle, and we can split these up. We're running out of room over here, sorry. X equals 0, x minus 7 equals 0, x plus 2 equals 0. So we get positive 7, negative 2. So we actually have 3 solutions on this one. Again, not a quadratic. Negative 2, 0, and 7. It has 3 solutions because that one got ugly. It is a cubic function, so it has x to the third, which means it has 3 solutions. It's a nice lead into polynomials. We're not at polynomials yet, but that's just kind of like a preview of it. And then again, if we were to graph that, whoops, go to y equals my function. You always want to put in your original function here just so that in case you factored it wrong, then you can catch your mistake. Negative 5x squared minus 14x. Oh no. Let me try that again. Sorry. Okay, now I got it. I just had to hit the right arrow to get out of the exponent. That's my bad. I'm gonna hit graph. And why? What have I done? Hold on. I see it. I forgot my X. I'm struggling on this one. Sorry. Now graph. There we go. I'm like, I know I got this one right. Okay, so when we graph it, we can see the function goes through -2, 0, and 7. So that's what that looks like. You can kind of zoom out so you can see what the graph looks like a little bit more. There you go. That's what that graph looks like. Isn't it so pretty? Okay, moving on. Let's not dwell on that. Last one, we have x squared minus 12x equals -36. Our zero product principle says that it has to be 0 that it's equal to, and we have -36. This isn't a reason to give up. It's just a reason to have one more little step. We're going to add 36 over here. So we have x squared minus 12x plus 36 equals 0. Now we can factor and then solve. And we get the same solution because if you remember from one of my previous videos, this is actually x minus 6 squared. So it's the same root. It's a double root, basically. When we get into polynomials, we'll talk about multiplicity and what that looks like. But basically, what happens is this one just touches down at 6. And it just has basically one root. We call it a double root. And I can show you what that looks like because it's cool. So we have, I'm not going to put in the original equation. I said in the previous example, put in the original equation, but it's equal to -36, and that's not how the calculator works. I'm going to put the second one in, x squared minus 12x plus 36. Make sure you type it correctly. Go to graph, and that's how you can see. Again, ignore this box plot. I should have just taken that off, but just ignore it. The green U-shaped graph is what we're looking at, and it does indeed touch down at 6. So that's that. It looks funny. That's why I paused. There it is. Now we can see it. Touches down at 6. So that is all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I will see you in the next one.